Hi, I'm going to talk to you today about STEM education. STEM stands for science, technology, engineering, and mathematics. So let's look at a short little video about what STEM is.
What is STEM? It's the acronym for Science, Technology, Engineering, and Mathematics, the disciplines that are vital for a thriving economy and a safe and healthy society. In kindergarten through 12th grade in the United States, most STEM teaching and learning focuses on science or mathematics. Comparatively little attention has been paid to the T, the products and systems that meet human needs, and E, the creative process used to design these things. And, for the most part, the four subjects have been taught in isolation. But new reform efforts, like the Next Generation Science Standards, are placing more emphasis on the connections between and among the STEM disciplines. To understand how this trend might affect teaching and learning in the future, we need to take a closer look at integrated STEM education, not just the individual subjects that make up the acronym. After all, in the real world, science relies on technology, mathematics, and engineering. And engineering depends on findings from science, the application of mathematics, and the use of technological tools. Imagine if K through 12 students were taught in ways that highlighted these connections. Would they learn more and more deeply? Might they see STEM disciplines as more relevant to their lives? Could it lead more of them to pursue STEM courses and careers? The answers to these questions depend in part on how integrated STEM education is implemented in schools and in out-of-school settings. Research suggests that implementation has to balance learning in the individual STEM subjects with more connected ways of learning. In addition, because it can be hard for students to make these connections themselves, teachers will need to make the connections explicit. Inside the classroom, some teachers may use instructional approaches like problem-based learning or engineering design, which are special kinds of problem solving, to introduce integrated STEM education to their students. Outside the classroom, students are being exposed to STEM connections in museums and science centers through after-school experiences like some TV shows and STEM-focused robotics competitions and in internships. However, we need more research to better understand the potential benefits and limitations of integrated STEM education for students, teachers, and schools. What, for example, are the implications of integrated STEM education for how schools are organized? How can teachers be better prepared to teach in integrated ways? And how can we test kids to determine what they are really learning and able to apply as a result of integrated STEM experiences? The list of questions is long, but getting answers is important for students, teachers, and the nation. For more information about integrated STEM education, check out the STEM integration.
Okay, so that was a video talking about how we need to integrate it. And it mentioned the Next Generation Science Standards, which are really a hot topic now. Everybody's digging into them. And if you'll look, they have included engineering and design. I pulled just a sample. This is elementary. Define a simple design problem reflecting a need or a want that includes specific criteria for success, constraints on material, time, or cost. And then we can come over here and look at this next. It says defining and eliminating engineering problems, develop possible solutions, optimizing the design solution. And then their science and engineering practices. This is what they want students to get some practice doing, and basically this is thinking and problem solving. They want students to be able to ask questions and define problems, plan and carry out investigations, and construct and explain their design solutions. And hopefully we can, through the integration of STEM, figure out how engineering, technology, and science affect our natural world. So how can we introduce STEM to elementary students here at Eminence? Robotics. is a perfect way to do so. I am showing you, that was a clip from a robotics class with middle school, and a student designed the robot and then programmed it to deliver trees to the orchard. There was a challenge there, a problem. Hurricane Sandy had blown trees on the street. The ship had been brought to shore, and the robot had to push it back. You'll see there's a bridge. The bridge needs to be repaired. So that's just one example of a problem that requires students to know their restraints.
They just both at once.
This clip shows students repairing. They had to take apart the damaged bridge and bring the ambulance back to the station to repair it. It had a missing wheel. And there's lots of problem solving and restraints that students can identify in this problem. They can only use so many motors. They have so much time that's given to them, that's allowed. And then they had to come up with different designs on how to retrieve this ambulance and how to repair the bridge. And every group came up with some different device to collect objects or to repair objects. And then this, I'm just going to show you a small little clip. I got this off the internet. We did this in class, but I couldn't get my video over. But I like this one because at the very beginning, they're showing you some restraints. They're showing you here that the robot had to weigh so much and it had to be a certain size. So this really, with a competition, kind of embeds those engineering and design definitions and concepts into their mind. The robots are wrestling, and you'll notice that they've come up with two different designs here. They had to be programmed. They have light sensors, and they had to be able to program them where they would not run off the mat. They had to come up with designs of how they would push the other robot off. And you'll notice everybody's design is a little bit different. And you'll notice the other robot went off and then came back on. They're going to show you several competitions. The video is kind of long, but I just wanted to show you a few.
You remember what it was like in school. It was boring. You sat in class.
So we're going to look at project-based learning, and probably more so is probably using problem-based learning. Could use project-based learning in a more advanced class.
Memorized as much as you could and tried to pass a test at the end. But is that good enough? These days, school can be more interesting and effective by focusing students on work that matters. This is project-based learning explained. Most adults live in a world of projects. Whether it's a job assignment, home improvement, or planning a wedding, we need to actively solve problems. But unfortunately, schoolwork looks more like this than this. Let's take a look at this project-based world. Meet Claire. She was recently presented with a challenge. Her company, Super Suds, makes soap, and it was up to her to find the most earth-friendly way to produce it in the future. Her boss gave her a budget and a few requirements, and it was up to her to come up with a solution. She organized and managed a team who researched the options and created materials summarizing the issues. Claire's team asked for feedback and presented their findings to the boss. Claire came out of the project looking like a rock star, and she learned a lot about green products. If you look closely, Claire's success involved critical thinking, collaboration, and communication, things that aren't often taught in traditional classrooms. The world needs more Claires, so how do we get them? The answer is project-based learning, or PBL. By focusing students on a project, teachers put them on a path that deepens their knowledge and builds skills they'll need in the future. Here's what I mean. Mr. Simmons has always been a good science teacher, and his students do well on Friday's tests. Unfortunately, what they learned was gone by Saturday morning. That wasn't good enough for him. Soon he learned about project-based learning and decided to give it a shot. Mr. Simmons got the idea for his first project on microorganisms when nearly half of his students were suddenly absent with the flu. He asked his students why they thought so many of their classmates got sick at the same time. That lively discussion produced a lot of good questions and a list of things the kids wanted to know. Mr. Simmons then announced their project was to help elementary school kids understand, how can we not get sick? After dividing the class into teams, he got them started on the project. It was up to the students to ask questions, research, collaborate, give each other feedback, and figure out the best ways to make their points clear to children. One team chose to make an educational video on the connection between hand washing and avoiding the flu. Another chose to create posters to show how viruses spread. The project teams showed off their final work to an enthusiastic audience of parents and their children at a nearby elementary school. Sitting in the front row was our good friend and local rock star Claire, who saw a bit of herself in the students. It was clear that the project was a success for the students, the audience, and Mr. Simmons. His students practiced critical thinking, collaboration, and communication. The project wasn't about memorization, but learning in depth about viruses and how to prevent spreading disease, a lesson they will never forget. At the end of the presentation, Claire introduced herself to the students and told them that they were rock stars and that the world needs more people who can think like them. To learn more about project-based learning, go to BIE.
All right, so robotics is a really good way to implement not only project-based learning, but the next generation science standards that include engineering and design. So if we were to think about implementing a robotics team for the elementary school, I put together a budget, and you'll see that to participate in the STLP program, one team registration would be $75. A robotics kit would be about $370. That's one kit. A mat is $150. If you compete, you could possibly take 2 trips. One is regional, one is state. That's about $600. And for a total of $1,195. In the past, and I'm not real certain if it'll still be the same, the district has funded the registration for STLP and a mat and the bus trip. Don't know if they'll still be able to do that or not. And in the green, I put the kit, to purchase a kit. I know we got a 21st Century grant. Not certain if we'd be able to use that or not. I have a question mark. I'm throwing out suggestions, and maybe between our principal and our site base, we can decide and find out how to fund this. But you'll look, I put minus the kit, $825. Once you buy a kit, you can use that kit over and over. So for one team each year, it would cost $825 to sustain that program. And then I went ahead and laid out if you had 2 teams and 3 teams. I laid those out in the same manner so you could look at that. A lot of teams do 4 students on a team. So if you did 1 team, you're looking at 4. If you did 2, you're looking at 8. If you're doing 3, you're looking at 12. Obviously, the more kids you have, the more students that could participate, and that may be a discussion among site base and the principal as to how much we can actually afford and how many kids we can participate. Because when you get beyond 4 kids sharing a kit, even 4 is kind of hard. It kind of loses its impact and its value. So why should we pursue this? And in reading the research studies comparing learning outcomes for students taught via project-based learning versus traditional instruction show that when implemented well, a project or problem-based learning increases long-term retention of content, helps students perform as well or better than traditional learners in high-stake testing, improves problem-solving and collaboration skills, and improves students' attitude toward learning. And this was a study done by Strobe and Van, Walker and Leary. And also, one of the fastest growing jobs are jobs that are not being filled by U.S. citizens. This is according to the U.S. Department of Commerce, are STEM occupations. They are growing at 17%, while others are growing at 9.8%. And then they're kind of showing the starting salaries for a civil engineer, $47,000, a chemical engineer, $60,000. So why wouldn't we steer our students towards some STEM-related jobs since they're going unfilled by U.S. citizens and they're having to recruit foreigners? So if America hopes to effectively address the STEM pipeline problem, we must find ways of developing young learners interested in STEM education and must sustain that interest throughout the remaining school years. So if we can get those students interested while they're in elementary, and we're looking at students who are, strong in math and science, and we can keep them interested, then we can get that pipeline going from elementary, middle to high school, and help our kids fill those high-paying, wonderful jobs. And we want to steer kids that way that are interested, and that's their talent. Not that we want every kid to go that way, but kids, we want them to have jobs that are fulfilling. For example, my son loves math and science. He says right now he wants to be a mechanical engineer, so why not spark that interest and keep it going all the way through school? Because sometimes what happens, we lose kids along the way because we don't have STEM integrated into the curriculum, and they lose sight of these engineering jobs and pursue something else, maybe not so much of their interest. So I've just listed here the resources, cited my sources where I've got my information, and I hope that you would please consider starting a robotics club at the elementary school, kind of starting a pipeline, and preparing our kids for future engineering jobs. Thank you once again. If you have any questions, I'll take those right now.